Okay, hi there, I'm Hao, and this is just another video of me solving randomly code problem. So today we need to build a balanced binary search tree. So we're given the root of the binary search tree, which it is already a binary search tree, but it might not be balanced, right? It's gonna be something like this. We need to return a balanced binary search tree for the same root value. To more than one answer and return any of them. Right, balance mean the difference between the high difference between two subtree of every node not gonna be greater than 1. Right? So this is valid, it is also valid, right? The difference should be 1, the difference is 1. Right? Okay, so how do we gonna do this? So if we have a sorted array, then we can do it, right? If we have 1, 2, 3, 4, right, then we can use an in-order traversal to do this, right? We can have a left and a right pointer, right? So we can process the left and the right pointer. So we can have a mid index, right, equal to the left. I'm not gonna do the math here, but you got the idea. It's just binary search. Mid index, right? So it's the index, right? The mid index is gonna be 2 or only 1, right here, right? I'm just gonna use a pointer here, right? Right. So yeah, okay. So after we find the middle node, right? So the idea is that because the array is sorted, right, and we want the tree to be balanced, so it means that we want half of the node to be on the left, and then half of the node to be on the right, right? Right. If we have 4 elements, right, then we want half of the node to be on the left, and then half of the node to be on the right. Right? So we need to pick the parent node to be in the middle, right? The parent node always going to be in the middle. If we have 1, 2, 3, 4, 5, we pick the parent node to be in the middle, which means we're going to have 2 nodes on the left, 2 nodes on the right, right? Which give the tree balance, right? And we can do the same thing at the sub level. Right? We have 1 and 2, right? We're going to pick 1 as the parent. So we have 1 node on the right and 0 node on the left, right? The difference never going to be more than 1. Right, so that is the idea there. Right. Yep. So let's start it. So when the left and right is 0 and 3, right? The middle gonna be 1. So we create a new node, node 2, right? It is done, right? It is done, right? The value that passed into this node are gonna be 0. The left and the right pointer, right? 0 and 3. Right? So we go to the left, right? So when we go to the left, we need to update the left and the right pointer. Right? So this is the parent node, right? So whatever on the left gonna be here, right? So 0, and then mid minus 1, which is 0. Right? So so 0 and 0, right? Which is just an array of 1 here like this. So this is going to be the parents, right? Which is also the middle node, right? The middle node going to be here. So this is 1. Right? And we keep going, right? We go to the left, right? This is come 0 and minus 1. So when left is when the left is larger than the right, we just return no, right? So we finish the left, we go to the right. We go to the right. The right is gonna be 0. Gonna be the mid plus 1, right? 1 and then 0, right? So now here the left is also greater than the right, so we return no. So we finish the left here. Now we process the right side. So if we go to the right, it is our range, right? Right. So mid plus 1, which is 1. The right bound gonna be the same, 1 and 3, right? Oh no, the mid is 1, right? So mid plus 1 gonna be 2 and 3, right? So we're gonna have 2 elements here, 3 and 4, right? And then we pick the one in the middle, which is 3, right? To create this node, so this is done. And then we keep going left and right, right? So when we go left, we increase the mid, the left bow, right? Let's see. So the mid gonna be at index 2, right? Yeah, index 2. 2 plus 1 is 3. 3 and 3. If we go left, wait, hang on. We have 3 and 4, right? Which is index 2 and 3. Right, 2 plus 3 is 5. 2 plus 3 minus 2 divided by 2. So this is 0, right? Which is index 2. Yeah. Okay. So when we go to the left, oh yeah, two stay the same. And the right bar gonna be mid minus 1, right? Mid is 2 minus 1 is 1. So left is greater than right, so we return null here. Example here, we keep the right bar, update the left bar, gonna be 2 plus 1 is 3, right? 3 and 3, so no gonna be 4, done, right? This also be no and no. So we have successfully created the tree, right? Oh, this one, right? 2, 1, 3, 4. Okay, so let's code this up. Oh yes, and before we start, how do we get the sorted array? We get the sorted array by doing a in order traversal, right? If it is a binary search tree, we do an in order traversal. Right? In order traversal is we process the left first, the mid, right? Mid, and then the right, right? Because we want a sorted array, right? But whatever to the left gonna be smaller, right? So we process the smaller one, and then the element, and then whatever is larger. Right? So to get a sorted array, we need to do an in order traversal. Okay, so we have an in order traversal type function here. So if the node is null, right, we just return. Otherwise, we're gonna process it, right, in order left, right, and then process the node in the middle. In order to push node value, we need to create that array, of course, in order. We go to an empty array here, and then we can go in order, nothing in the loop, right? And at the end, we can return view, starting out at the left and the right pointer array in order length minus 1. Okay. So here we take in two pointer left and right. Okay. Left and right is right here. So what is our base case? So if left is larger than right, right, we just return null. Right? Otherwise, we're gonna calculate the mid index, left plus not the floor of right minus left, whatever 2, right? And then we can return a new node, new tree node here, right? The first argument gonna be the value, which is the value at the middle index, right? And the left and the right, just which is gonna be left mid minus 1, and then if we go to the right, right, we keep the right bound the same, and the left bound gonna be mid plus 1, right? So if you look at the definition here, we're taking the value, the left and the right, right? Right, so the left gonna be if we go left, right, then we have to decrement the right bar gonna become the mid pointer, mid index minus 1. If it goes to the right, then the left bar gonna become mid plus 1. Okay, and this is pretty much it. Let's try that. And it work. Thank you for watching.